After populating the column related to parts cost per unit, now we can go to finishing the second row. And you have noticed that when it talks about the second row, it's not about second run, my friend. It is about the second row. The first row is the header and the second row is first run. So here it is telling you that let's finish the second row, and it means we should simulate the first year demand. That is normal. We are going to do it. And here it put the final formula for doing the profit that I'm going to show you with the Excel file. Okay, here we are gonna simulate the demand. To simulate the demand, like the things that we discussed last week, and also you can find in the PowerPoint. As soon as you put here, you put this, and after that you put rand here, mean, and standard deviation. Pause the video and do it yourself. Here we got the first simulation, and if I show you the formula, you can see also the formula here. Norm.inverse rand, because I'm not freezing it for the reason that I told you, and after that here we have the mean, average, and standard deviation. Now to populate it, you just need to drag it down. By the way, one point to tell you, since you have all the things here, Excel is smart enough to recognize where it should start and where it should end it. So just bring your this white plus sign, that is arrow, plus sign over here, over this small square at the right bottom of the cell, and as soon as you are hovering over it and it is in the correct location, it changes its shape to this narrow black plus sign, and double click, left click on it, and that's it. It would populate everything to the down, because it is smart enough in that situation. When you double click it, it's continue on that. So here we have, and double left click helps you with that. Now the only things that we need to do to finish this table is going for the profit part. For the profit part, equal, because we talked about the formula before, it is equal the price minus direct labor cost minus parts cost, close the parentheses, times the demand, because you are gonna sell that many items. The demand, that is M3, and all the things minus the administrative and advertising cost. In that situation, I put the formula to calculate my profit for run first. And the formula that I used is exactly the same as the one that we discussed today. And it is the selling price, makes sense, minus the cost you have incurred because of making that product. That is direct labor cost and part cost per unit, close parentheses, times all those things at the demand, because they are the things that they are gonna sell. And when you have all the things minus the administrative and advertising cost, and you come up with this answer. So I'm gonna populate it the same way that I told you, and let me also show you the formula just in case you want to know. You see the formula now? Now you cannot see it. Okay, here you see the formula that we have for this, and by double left click, we get all the results. Now we have the profit, the profit of this system simulated for 1000 runs, and now we just need to start some sort of analysis on them to make decision. In this slide, it encourages you to run the simulation model for other. Okay, I need to also for other. Sorry for the time. For other 999 times that we have already done that you can see it here, and so we are good with that with this slide. And here now you have 1000 numbers. What do you want to know now? Of course, one of the things that you want to know now about this is average of all these things, to see that what is the average. If average appears to be negative, okay, so it means that you are gonna lose money. But if it is positive, it means that okay, you are going to make some money. What about the amount? It goes into financial aspect, that you see how much investment you have had, and if do you like this return of investment and all those things. But in terms of simulation, that is something to help you, provide you with more insight regarding the problem that you are struggling with. We are done. So just I'm going here and to show you that now we have these. And now I'm gonna calculate the average and standard deviation. So for the average, we have please feel free to ask if you have any question, even if it is not in the area that we discuss simulation in our class. For example, if you have some other idea to apply this technique and see what would be the results, feel free to discuss those type of things with me as well if you like, because it's a very practical approach and you can use it for many of the things. And here now we have the average of profit that they are gonna make is, let me put that separators so you can see it better in front of you. Number 0, use this, and now it's gonna be better. Because it's the result of what we tried to achieve. Okay, so you see it says that the average is $717,721. So they are going to make money. Let's check if they also lose money in some of the losses. Yes, you see, for example, in the fourth run, they have lost money. How much? Minus 2,890,200 68. You see, there are many. So it means that in this case, there are chance of losing money. But averaging over 1,000 years, 1,000 runs, it says that no, it has tendency to make money. Now, again, I'm telling you to take this decision, to go for this business or not. It depends on some other things. But now you have a good insight to help the people who want to do this decision making, to make this decision with this insight that now you have. Of course, for example, if you are putting no money on the table and you are making $717,000, that's very good. But if you are putting $1 billion for investment and you are making that money, that needs to be discussed. That is not the focus of our course, not for homework or anything. But if it is asked you for your opinion, of course, it would tell you some more details about the problem. For example, in this problem, as far as I remember, it didn't tell us anything about investment. So it means that they just do it, for example, with something, or they have calculated all costs, and in that situation, that there is no initial investment and everything is available. For example, you go for a ready factory, or it is already over there, or it is something that have paid for, and so it seems good because they makes money. And let's go for the standard deviation. A standard deviation tells you that how much the numbers that you generated here by simulation are volatile. If, for example, the standard deviation gives you a big number, that means that be careful. There may be risk of losing money in some of them. But if the standard deviation is small, it means that, okay, the average is 717 and the deviation from that would be small and it never gets to losing money. But we just noticed that it gets. So the standard deviation should be something considerable. So just let's put these things, the numbers that we have. I guess it was L. Yeah, L 3 goes to. You see now the final calculations for average and ST, and as we predicted, the standard deviation is a large number because you can see some of the simulations that generate $1 million profit, and also you have some that generate minus $400,000. So it means that the situation is very volatile and the investor should be careful. And one of the reasons for this volatility is this normal demand, because demand has the average of 15,000, but it has a standard deviation of 4,500. So it means that the volatility is a lot, and you see how incredibly simulation tells you about that, and a simulation that we just did with Excel. And I guess for this Excel sheet now we are fine. The last slide regarding each simulation case is the final decision that we talked about it, that it is a matter of discussion about that. And now in this situation that we are going to make this, and a standard deviation is that, and the average is this, should we go on or not? That is not the focus of our class this semester, because we just focusing on some sort of predictive analysis, not prescriptive analysis. Okay, now you're good to go for the second simulation case that we have together. The second simulation case that we are gonna do together has the same basics as the previous one, and we just need to read it together and extract the important parameters and start generating the random numbers and the formula, and that's it.